energy conversion, and power. Energy changes takes place when most systems are in operation. For a falling body, the energy change involves potential energy and kinetic energy. For an oscillating pendulum bulb, the energy change is also potential and kinetic energy. The energy of an object at a height above the ground is potential energy, which is mgh. If it falls from that height, the potential energy decreases, while the kinetic energy increases. Just before it strikes the ground, the energy is completely kinetic energy. Power is the time rate of using or expending energy. In formula terms, power is equal to energy expended divided by the time taken to do that. Power is also equal to work done divided by the time taken to do the work. The unit of power is the watt. Since work done is equal to force times distance covered, then power is also equal to force times distance covered divided by time taken. Power is equal to force times speed or velocity. In simple form, P is for power, F for force, V is for the speed. Example 1. A body rolls down a slope from a height of 100 meters. Its velocity at the foot of the slope is 20 meters per second. What percentage of its initial potential energy is converted to kinetic energy? Take acceleration due to gravity as 10 meters per second squared. The options are A, 15%, B, 20%, C, 35%, and D, 40%. The solution is as follows. The potential energy PE of the body at the top of the slope is obtained using mgh, where m is the mass of the body, g the acceleration due to gravity, h the height. To get the potential energy, m times 10, we are told the height was 100 meters. Thus, the potential energy is 1000 m joules. At the foot of the slope, the energy is kinetic. At the foot of the slope, kinetic energy is given by half mv squared. So the kinetic energy will be half times the mass of the body. The velocity we are given as 20 squared. Ke will give us half times m times 400 joules. This we divide this to give us 200. So the kinetic energy is 200 m joules. Thus, the percentage of the kinetic of the potential that has been converted to kinetic is percentage of PE changed to KE is equal to 200 m divided by 1000 m times 100%. This will knock off this, 2 of this, m will go. That percentage is 20%. Option B is correct. Is correct. Example 2. How long will it take a 60-kilogram man to climb a height of 22 meters if he expended energy at the rate of 0.25 kilowatts? Option A, 5.3 seconds. B, 34.5 seconds. C, 41.6 seconds. And D, 52.8 seconds. The solution to the problem is as follows. First, the information we can get from the question is as follows. 1 is the mass of the man. The mass is 60 kilogram. We are also told is at a height of 22 meters. The acceleration due to gravity is provided 10 meters per second square. We are also given the power P, as 0.25 kilowatts. We have to change this to watts. This 0.25 times 1000 watts, because a kilo is 1000. That will give us power of 250 watts. Then we are asked to find the time it takes to get this done, to acquire this power. Power is equal to energy expended divided by the time taken. And that energy is potential energy. Power is potential energy at that height divided by the time taken. We have 250. The potential energy, of course, is mgh. Divided by time. 250 for power is equal to 60 times 10 times 22 divided by the time taken, which we are to find. 250 is equal to 13200 divided by the time taken. Time taken is therefore 13200 divided by 250. The time taken by the time we divide will give us 52.8 seconds. Option D is correct. Example 3. An object of mass 50 kilogram is released from a height of 2 meters. Find the kinetic energy just before it strikes the ground. Take acceleration due to gravity as 10 meters per second square. Option A, 250 joules. B, 1000 joules. C, 10,000 joules. And D, 25,000 joules. The solution to the problem is as follows. Just before it strikes the ground, the initial potential energy is converted to kinetic energy. Just before it strikes the ground, initial potential energy is equal to kinetic energy. That means mgh is used to calculate the kinetic energy. The mass is 50, this is 10, the height is 2. That will give us the kinetic energy just before it strikes the ground. Ke is therefore 1000 joules. Option B is therefore correct. Example 4. A vehicle of mass m is driven by an engine of power P from rest. Find the minimum time it will take to acquire a speed v. Option A, mv squared over p. B, mv squared divided by 2p. C, mv divided by p. D, mv divided by 2p. The solution to this problem is as follows. The engine started from rest and it acquired a speed v, that's the final speed. So the energy used is kinetic energy. Kinetic energy of engine Ke is half mv squared. Now this energy is used for a particular period of time to acquire the power. Therefore, the power of the engine is equal to kinetic energy used divided by the time taken. Power is P, kinetic energy is half mv squared, time taken T, which could be rewritten as P is equal to mv squared over 2T. This means T is equal to mv squared over 2P. Option B is correct.